Hello students, today we are going to discuss convolution sum. So in previous class already I told you on the basic theory of the convolution sum, how you find out the convolution of the signals. If input signal is your x of n and h of n is your transfer function, how you will get the output, that is your y of n. We are going to find out the y of n if x of n and h of n is given. So how to find out the y of n? In signal processing, this is one of the most important chapters, and if you will definitely, if you will get one long questions from the convolution sum. In convolution sum, what is actually we are going to calculate, that is your response of the signal, means output of the signal. If there is a system, since this is your system, and if there is your input and this is your output, if input is your x of n and if there is a system, there is a transfer function, that is your h of n, and you are going to calculate, that is your y of n, and this is your response. So y of n is nothing but, that is your x of n, that is your convolution of, that is your h of n. If there is a system by means of transfer function, so transfer function of x of n, y of n is nothing but your transfer function of, that is your x of n. So in convolution sum, if x of n and h of n is given, we have to find out, that is your response of the signal, that is your y of n. So in case of the convolution sum, x of n and h of n is given. In previous class, so already I told you there is a mathematical formula to how to calculate the convolution sum if x of n and h of n is given. And here there is a y of n and there is a formula, that is your sigma k equal to minus infinite to infinite, that is your x of k into h of n minus k. This is a basic formula. If x of n and h of n is given, if you apply this formula, y of n equal to x of k into h of n minus k, then you can find out, that is your response of the signal, that is your y of n. So there are some procedures, already I told you in the previous class. There are, what is the procedure if x of n is given and simply x of n is nothing but, that is your x of k. If h of n is given and this is nothing but your h of k, the first you have to folding it, that is your h of minus k, that is your folding. Already I told you in your previous class. Then after folding, then shifting. After folding, then shifting. Then after shifting, then multiplication. Then what? Multiplication. In this way, for each sample, we have to calculate the response of the signal or the output of the signal, that is your y of n. So here x of n is given. First of all, in x of n is given, x of n equal to 1 for n equal to minus 2, 0, 1. The sample exists at n equal to minus 2, 0 and 1, and the value will be 1. So if you will draw in a graphical representation of the signal, x of n equal to here, that is your what? Suppose let this is your 0. If this is your 0, let this is your 1, and you mark it here too, and like this. For n equal to 0, the x of n, if n equal to 0, x of 0, that is 1, and that the value will be what? That is 1. For n equal to 1, for n equal to 1 also 1, for n equal to 1 also 1, that is 1 here. Then n equal to minus 2, here minus 2 also 1, that is also 1. Then n equal to minus 1, that is 2, for n equal to minus 1, that is 2. This is your 2. The sample exists minus 2, minus 1, 0, 1, 2, and the x-axis is your n and y-axis is nothing but what? That is your x of n. This is a graphical representation of a signal, and this is your functional representation of signal. First, the signal is represented by means of this functional representation, and here you can convert it functional to your graphical representation. Then h of n, or transfer function h of n, here h of n equal to here del of n is nothing but your impulse signal, and the which amplitude is also 1 here. Del of n means for n equal to 0, the impulse signal exists. For n equal to 0, the del of n, that is 1. This is your n, and this is your what? H of n. For n equal to 0, that is 1. For n equal to del of n minus 1, this impulse exists at n equal to 1. For n equal to 1 also, there is an unit impulse signal, that is value is 1 here. If this is your n, this is your h of n. So h of n is here represented by means of shifted and scaled impulses. Del of n equal to, for n equal to 0, that is 1, and n equal to 1 also what? That is your minus 1, because this is your minus 1. N equal to 1, that is minus 1 here. N equal to 1, that is your minus 1. This one. That is your what? This is your minus 1. So that's why this is your function. This is your sequence representation, and this is your graphical representation. This is your x of n, and this is your h of n. The sample exists at n equal to 0, because del of n, the sample exists at n equal to 1. For n equal to 1 here, the value will be what? Minus 1, because minus n here multiply with 1, that is your minus 1, like this. The x of n and h of n is given. This is an input to you. The question is given x of n and h of n, and if you have to simplify this signal x of n and h of n like this, you have clearly, you know where is your sample exists and where is your sample is not present. So in this way, if we have not yet started to find out the convolution sum, and the procedure is what? X of n, k, h of k, folding, shifting and multiplying. First of all, step 1. In step 1, already I told you in your previous class, in step 1, that is your starting point of y of n. Y of n is your, we are going to determine the output y of n. That's why the output signal y of n, that is your what? The starting point of y of n. Starting point of y of n. Starting point of y of n is what? Already I told you in the previous class. Starting point of y of n. Y of n is your what? We are going to evaluate, or we are going to determine the response of the signal, that is your y of n, and the starting point of y of n equal to the starting point of x of n. Starting point of x of n. Starting point of x of n plus starting point of h of n. That is starting point of x of n. Look at this here. In graphical representation also this, and you can also in sequence representation also you can represent it what? N equal to 0, that is 1 here. That is your, put the arrow mark. This arrow mark indicate for origin. N equal to 0, the sample exists at 1 here, and 1 also 1. N equal to minus 1, that is 2. Then n equal to minus 2, that is 1 here. This is your functional representation of signal x of n. This is your graphical representation of signal x of n, and this is your sequence representation of x of n. And x of n is here, and h of n is here. The starting point of y of n is your output signal or response of the signal. Y of n is your starting point of x of n here. Starting point of x of n is what here? This arrow mark indicate for n equal to 0. This is your n equal to minus 1, and this is n equal to minus 2. So starting point of x of n is nothing but here the starting point. This is your starting point. Where? This is your n equal to 0. This value is nothing but what? This is your n equal to 0. So that is your n equal to minus 1. This is your n equal to minus 2. So starting point of x of n, that is your minus 2, plus starting point of h of n. Similarly, this arrow mark indicate for n equal to 0. So starting point of h of n is nothing but n equal to 0. That is your minus 2 plus 0. That is what? That is your minus 2. Okay. This is the starting point of y of n. Then right extreme of y of n. Y of n is your what? Already I told you. Y of n is your output signal, or the signal we are going to determine or going to evaluate. The right extreme of y of n equal to, that is your what? XR plus HR. XR, right extreme of x of n. Right extreme of x of n. Right extreme point. This is your starting point and this is your ending point or extremum point. That is your n equal to 0, this is your n equal to 1. So right extreme of XR value is nothing but 1. HR, right extreme of h of n, that is your 0, this is your 1. That is what? That is your 1. That is your 2. So right extreme of y of n, that is your 2. Therefore, so the length of y of n, the length of y of n, the length of y of n is nothing but L plus m minus 1. L plus m minus 1. That's why the n will be varies from, therefore n equal to, that is what? The varies from -2 to 2. N equal to -2 to 2. -2 to 2. -2 is your starting point of y of n and ending point of y of n, that is your 2. The value varies from n equal to what? -2 to 2. -2, -1, 0, 1, 2. That is your 5. So -2 to 2, that is your 5 intervals for different values of n. We will calculate y of n. For n equal to -2, calculate y of -2. n equal to -1, calculate y of -1. n equal to 0, calculate y of 0. n equal to 1, calculate y of 1. n equal to 2, that is your y of 2. That even for 5 values of n, we are going to calculate y of n. Check it whether L plus m minus 1 5 or not. Length L is nothing but what? Length of x of n. So length of x of n is how much? 1, 2, 3, 4. That is your 4. Plus m, the length of h of n. Length of h of n is how much? 2. That is your 2. Minus 1. 4 plus 2, 6 minus 1, that is your 5. So that's why this 5 and this will be satisfied or not. N equal to -2 to 2, -2, -1, 0, 1, 2, that is your 5 intervals for n. That's why this is match or not. That's why your initial procedure is right. Then come to our how to folding, how to shifting, how to multiplication for each different values of n, for -2, -1, 0, 1 and 2. Next, that is your what? Here x of n, that is your what? 1, 2, 1, 1. H of n equal to 1 minus 1. Here, this is important. 1, 2, 1, 1. Starting is -2 here. Starting is 0 is here. And here also, this is your h of n. You may convert x of n to x of k. And this is nothing but what? That is your x of k. Same thing. That is your 1, 2, 1, 1. H of k is your what? That is your 1 minus 1. In a sequential representation, if you do in the graphical representation here, this is your 0 for n equal to, this is your 1, this is your also 1, this is your -1, and this is your -2, and this is your 2, and also this is 1. This is your x of k. Then h of k here, that is for 0. For 0, that is 1. And for 1, that is your what? that is your minus 1. This is your k, this is your h of k. Then we have to find out that is your h of minus k. First step, that is your folding. For folding, replace n by minus n. Replace n by minus n. Whatever the sample exists at n equal to 0, as it is, for 1, go to minus 1 and minus 1 goes to 1. Then whatever the value at n equal to 2 goes to n minus 2. Whatever the values at n equal to minus 2 go to or shifted to h equal to 2. If h of k, if you fold like this is your 0. Whatever the 0 as it is, this is 1. Whatever the minus 1 here, this is your 1. It becomes to minus 1 here, and this is your like this. For minus 1 here like this. Okay, this is your h of minus k. This is your k, h of minus k. For n equal to minus 2. For n equal to minus 2. Already I told you in the previous slide, our starting point n equal to minus 2 to 2. This is your starting point of y of n, that is your minus 2. First of all, we will calculate y of minus 2. For y of minus 2, for n equal to minus 2, that is your y of minus 2. So y of minus 2 is nothing but what? K equal to minus infinite to infinite, x of k, h of minus k minus 2. Minus k minus 2. If h of minus k, folding already, you know, after folding, then shifting h of minus k minus 2. H of minus k minus 2, whatever the value, each samples shifted by to the left by 2 units. That's why h of minus k minus 2. That is your each sample shifted at whatever the n equal to 0, go to n equal to minus 2. Whatever minus 1 goes to minus 3. So this is your 0. You can mark it here also, or easy for you. Whatever the 0 come to minus 2 here, this is 1. And this is whatever the minus 1 goes to minus 3, like this. This is your h of minus k minus 2. For h equal to minus k minus 2, in sequence representation, you can write like this. This is your 0, this is your 0, this is your 1, this is your minus 1. This is your sequence representation. Then multiply x of k into h of k. Multiply this x of k, this with h of minus k minus 2. So like this, what? Tell me, at n equal to 0, n equal to 1 into 0, 0. Then minus 1, 2 into 0, 0. Then 1 into 1, that is 1. That is your 1 also here. Therefore, y of minus 2, that is your 1. Okay. Y of minus 2 equal to 1. N varies from minus 2 to 2. That's why for different values of n, minus 2, minus 1, 0, 1, 2. Already n equal to minus 2 over y of minus 2 is 1. Then come to n equal to minus 1. That is your y of minus 1. Y of minus 1, that is your k equal to minus infinite to infinite, x of k into h of minus k minus 1. So h of minus k minus 1, your original folding, that is your h of minus k minus 1. H of minus k and minus 1 means each sample shifted to the left by 1 unit. Whatever 0 come to minus 1 here. Like this. This is 0. Then go to here 1 and here minus 2, like this. So h of minus k minus 1, h of minus k minus 1 in sequence representation, that is your 0, this is your 1, and this is your minus 1, like this. And you multiply here, you multiply this with this. H n 0, so 0 into 1, 0, minus 1, 1, 1 into 2, 1 into 2, plus again minus 1 into 1, minus 1 into 1, that is your 2 minus 1, that is your 1. Okay, or minus 1, 1 into 2, then minus 1 into 1. So therefore y of minus 1, that is 1, y of minus 1, that is 1. Then come to n equal to 0. Then n equal to 0, or n equal to 0, that is your what? Y of 0. So y of 0 equal to, that is your what? X of k minus k, k equal to minus infinite to infinite, x of k into h of minus k, because n equal to 0. So h of minus k is already there here. H of minus k is your what? That is your 1 minus 1 in sequence like this. This is your h of minus k. You can multiply this with this. That is your what? For 1 into 1, which equal to 1 into 1 plus minus 1 into 2. Minus 1 into 2. Okay, that's why that is your 1 minus 2, that is your minus 1. Therefore, y of 0 equal to minus 1. So already we have completed for different values of n. Our n varies from minus 2 to 2, that is your minus 2, minus 1, 0. So minus 2, minus 1, 0 already we have evaluated. Then come to n equal to 1. N equal to 1. For n equal to 1, that is your y of 1. So y of 1 equal to, that is your k equal to minus infinite to infinite, that is your x of k into h of minus k plus 1. Your original is your folding. After folding, we are going to shifting. So that is your h of minus k, x of k into h of minus k. If it is 1 means plus 1. If it is minus 1 means this is your minus 1. So one is a delay, another is advance. So h of minus k plus 1, h of minus k plus 1, this is your h of minus k. And h of minus k plus 1 means each sample shifted to right by 1 unit. That's why h of minus k plus 1, whatever that 0 goes to 1, whatever minus 1 goes to 0. So that is your h of minus k plus 1, that is your here 0, and this is your 1, and this is your 2 like this. Whatever that is your minus 1, this is your h of minus k. After folding, we are going to shifting. Whatever minus 1 goes to 0. Here, sorry, this is my minus 1. Whatever 0, this is minus 1. Whatever 0 goes to 1 here, like this. This is your h of minus k plus 1, and which equal to, in sequence representation, that is your minus 1, and this is your 1. Minus k plus 1. And you have to multiply x of k into h of minus k plus 1. If you multiply this, the value is how much here? For n equal to 0, for k equal to 0, how, what? That is your 1. 1 into minus 1, that is your 1 into minus 1. Plus, then n equal to 1, 1, n equal to 1, 1. That is your 1 into 1, 1. That is your 1. The value is what? 1 into minus 1, plus 1, that will be 0. Therefore, y of 1 equal to 0. Y of 1 equal to 0. So already we have calculated the 4 values of y of n, minus 2, minus 1, 0, 1. Then come to n equal to 2. Last one for n equal to 2. For n equal to 2. For n equal to 2. That is your y of 2. Y of 2 equal to, same procedure, k equal to minus infinite to infinite, x of k into h of minus k plus 2. H of minus k plus 2. So that's why the value is how much here? This is your h of minus k plus 1. Minus k plus 1 plus 2, or h of minus k plus 2. If h of minus k is here, minus k plus 2 means advance. each sample unit shifted to right by 2 unit from h of minus k. From h of minus k plus 1 only 1, because already shifted 1 samples. Again if we shifted to another samples by 1 unit, it becomes h of minus k plus 2. So h of minus k plus 2 is whatever 0 goes to 1 here. That is your what? That is your 0, 1 in place. This is your minus 1. So that's why in 1, that is your minus 1. And here 1, that is 2. Here. So h of minus k plus 2, h of minus k plus 2 equal to, that is your what? 0. Then at n equal to 0, no samples exist here. At 1, that is minus 1, and this is 1. This is your h of minus k plus 2. You have to multiply x of k here, x of k into h of minus k plus 2. At n equal to 0, that is your 0, 0 into 1, that is your 0. This is your minus 1 for k equal to minus 1. For k equal to 1, that is minus 1. K equal to 1, that is your 1. So minus 1 into 1, that is your minus 1. That is your what? Minus 1 into 1, that is your minus 1. Only multiplied what? N equal to 0, 1, 2. 0, 1. For this is your minus 1 and this is 1, minus 1 to 1, 1, and anything else elsewhere, that will be 0. The h of minus k plus 2, that is your minus 1. Therefore, y of 2 equal to, that is your minus 1. Okay. So that's why y of minus 2, minus 1, 0, 1, 2. Therefore, our output signal y of n, which your determined signal y of n, the value is from minus 2, in minus 2, that is 1, for minus 1, that is 1, 0, that is minus 1, 1, that is 0, and 2, that is minus 1. Okay, that is your 1, 1, minus 1, 0, minus 1. This is your minus 2, minus 1, and this is your 0. For you can mark it as origin. For n equal to 0, that is minus 1. This is your y of n. If you check it, whether your result is right or wrong, your result is right or wrong, you can check it. To check your x of n, that is your 1, 2, 1, 1, and h of k, that is your what? 1, minus 1. Okay. Here, that is your 1, 2, 1, 1. Here, that is 1, minus 1. H of n, that is your 1, minus 1. Simply, you write it 1, minus 1. Simply multiply this with this. 1 into 1, that is 1. 1 into 2, that is your 2. 1 into 1, that is 1. 1 into 1, that is 1. Here, minus 1 into 1, minus 1, minus 2, minus 1, then minus 1. Like this. That's why y of n equal to, first 1, this is your 1. Then minus 1 plus 2. You have to add minus 1 plus 2. Minus 1 plus 2, that is your 1. Then minus 2 plus 1, that is your minus 1. Minus 2 plus 1, minus 1. Minus 1 plus 1, that is your 0. Then that is your minus 1. So already in first step, we have already for starting point of y of n, this is from minus 2. This is your n equal to minus 2, this is your n equal to minus 1, this is your 0. You can mark it as origin, this is for n equal to 0. And this is your minus 2. Here, the straightforward procedure, if x of n, h of n is given, on the very beginning, you can calculate your output y of n. y of n equal 1, 1, minus 1, 0, minus 1. Check it whether your answer is right or wrong. 1, 1, minus 1, 0, 1. Okay? 1, 1, minus 1, 0, minus 1. 1, 1, minus 1, 0, minus 1. So you can check it, your answer is right or wrong. So in 1 second, you also know what will be your output. If any calculation we have done through procedures by folding, shifting, multiplying, then finally we will get y of n equal to like this. But in 1 second, you can calculate the value of y of n if x of n and h of n is given, x of n and this is your h of n. If x of n and h of n is given, in 1 second you can calculate it. But in step-by-step procedure, using convolution sum by help of this formula x of k into h of n minus k, k equal to minus infinite to infinite, for different values of n, we have to calculate, we have already calculated y of n. If this, whatever we will get the y of n, and if we'll, using this method, you can check it whether your answer is right or wrong. So thank you very much. We will do again and more and more number of problems related to the convolution sum. Thank you.